Hello everyone, welcome to my channel NCRT Unplugged. We are doing chapter number 4, motion in a plane, class 11 physics, and in this video I'll explain you 4.2 article scalar and vector. Okay, so we need to understand what are scalar and vector. We are talking about because we are talking about two dimension, and we need to specify. We will classify physical quantities in two categories. These are scalar and vector. What are scalar and what are vectors? Let's see in the paragraph. Okay, so in physics we can classify quantities as scalar or vectors. Basically the difference is that a direction is associated with a vector but not with a scalar. Okay, so basic difference is the direction. A physical quantity having direction will be a vector, and a physical quantity with no direction which has no direction will be a scalar. Okay, a scalar quantity is a quantity with magnitude only. It is specified completely by a single number along with a proper unit. Okay, so just take an example and you understand, like distance between 2 points. I'll say what is the distance between this point and this point. Okay, so these are 2 points. So what you need to do, you will just say suppose 10 and a unit centimeter. What you did, 10, this is a number and this is a unit. Do I need to say direction in this case? There is no direction needed for this case. This is a vector distance. Okay, the total, suppose even a better example would be if a person travel in this way from A to B. So if I ask what is the total distance travel, so suppose that this distance I measure and it comes out to 25 meter. Okay, so this is the distance. This is a scalar quantity. But as we have understood in the case of displacement, okay, but I'll say what is the displacement, how much he has displaced, what is the displacement between his final and initial position. So now I need to specify a direction, and then displacement as a direction, I need to specify in which direction he has moved. So he have moved in this direction. Okay, so there is a need of to mention direction also. That will be a vector quantity. Okay, the quantities which need direction also, that are vector quantity. Example of vector quantity is force. Okay, because force act in a particular direction. Okay, more example is obviously velocity and displacement. Okay, so there are torque is one example. Okay, so there are so many examples that we need, that are all the quantities will classify them as scalar and vector. Okay, so now examples are the distance between 2 points, mass of an object. Okay, mass, there is no direction of mass, 10 kg, 20 kg, there is no direction. Temperature of a body, okay, 40 degree, 20 degree, there is no direction. And the time at which a certain event have happened. Okay, you will not say in which direction time is going. Okay, so that time has no direction. The rules for combining scalar are the rules of ordinary algebra, and it is very easy to combine, add scalars. Okay, suppose I have a body of 20 kg, another body of 40 kg. What is the combined mass? You will just add them, you will say 60 kg. Okay, simple algebraic sum algebra will do the math, the addition subtraction in this case. Okay, scalars can be added, subtracted, multiplied and divided just as the ordinary numbers. For example, now if the length and breadth of a rectangle are 1 meter and 0.5 meter respectively, then its perimeter is the sum of the length of the four sides. Okay, so you know how to do. If we are given this rectangle and the sides are 1 meter and 0.5 meter length and breadth respectively, then how to find the perimeter? You need not to consider the direction. Just add the four sides and you will get the perimeter, because this length is a scalar quantity. Okay, length of each side is a scalar and the perimeter is also a scalar. Okay, take another example. The maximum and minimum temperature on a particular day are 35.6 degrees Celsius and 24.2 degrees Celsius respectively. Then the difference between the two temperatures is 111.4 degrees Celsius. Then similarly, if a uniform solid cube of aluminum of size 10 cm has a mass of 2.7 kg, then its volume is 10 to the power minus 3 meter cube. Scalar, its density is this much. Okay, So this is also one example, because this volume, density, all are scalar quantities. There is no involvement of direction. Okay, so these are some example of scalar, but we will be more interested in is vectors. Okay, so first of all, a vector quantity is a quantity that has both a magnitude and a direction, and obvious the triangle of vector addition or equivalently the parallelogram log vector addition. Okay, so a vector is which has direction and magnitude also. Examples are displacement, velocity, acceleration, and force. And two and one more definition of vector is there. Okay, you will understand. I'll give you an example for this. Okay, you see electric current has magnitude like 2 ampere. When you come across electric current in class 12, okay, you have studied a little bit in class 10, then you see that direction, it flows in a particular direction. Even then it is not a vector, electric current. So why is not a vector? Because it doesn't obey this triangle of vector addition and parallelogram of log addition, any of this, because they are almost the same. So a vector will be called vector if it has direction, magnitude, and it obeys this law, parallelogram or triangular law of vector addition. Then it will be called vector. It has direction, it doesn't obey this, example current, not a vector at all. Okay, so a vector is specified by giving this magnitude by a number and a direction. Some physical quantities that are represented by vector are displacement, velocity, acceleration, force. Okay, so we give a direction also. To represent a vector, we use a bold-face type in this book. Thus a velocity vector can be represented by a symbol V. Okay, so for this book, what they have did, they are representing like this. Okay, they are making it in bold letters. So whenever there will be a bold letter alphabet comes, just understand that it is a vector. Okay, but in other books, what they do, they just we make an arrow above it. Okay, the symbol above the symbol of the physical quantity, and that represent a vector. Okay, since bold face is difficult to produce when written by hand, a vector is often represented by an arrow placed over a letter, say this. Okay, so as I told you, because in handwritten what we do, we just place a arrow about it. Okay, this way, like they have did arrow. Okay, and we can just, like I showed you, this way we put a arrow. Okay, in this book, bold letter is given for represent vector. Thus both V and this V represent a velocity vector. The magnitude of a vector is often called its absolute value, indicated by this sign, modulus. Okay, so but if we want to represent we want to only say about the magnitude, what we do, we just put this two straight lines that is called the modulus. We call it modulus. It represents the magnitude. Okay, like I'll just say this is equal to, and we can also write this like this. Okay, without this bold letter, that means we are talking only about the magnitude. Like V is suppose 20 meters per second. We are only considering the magnitude and not the direction in this case. Thus a vector is represented by the bold face. Example, capital A, small a, P, Q, R, with representative magnitude does not require light face. Okay, so when there you see this symbol in this book, light face, then you will say that it is only magnitude. And if a bold letter comes, then understand it has a direction also. Okay, so I hope this paragraph was clear to you. If you like this video, please give it a thumbs up, share with your friends to which you find this video can be helpful. Subscribe to my channel, press the bell icon, and thanks for watching this video.